Okay, I'm going to solve the following word problem. A high school is planning to build a new playing field surrounded by a running track. The track coach wants 2 laps around the track to be 1,000 meters. The football coach wants the rectangular infield to be as large as possible. Can both coaches be satisfied? So here's the track. Here's the infield where the football coach wants to maximize. And the track will be all the way around the whole thing, with these two semicircles together making one circle. Okay. Since 2 laps around the whole track are 1,000 meters, then 1 lap is 500. So we just divided 1,000 by 2 to get that. Since we have circles, or one whole circle together, we want to note that circumference is 2 pi r or pi d. So formula for 1 lap around the track, we want it to equal to 500, so the perimeter is 500. We have 2 lengths that we're adding, and 2 pi r, because that's the circumference of one whole circle. We want to isolate for L, so that we can substitute that into an area question. So we just rearrange the equation. 500 equals 2L plus 2 pi r. 500 minus 2 pi r equals 2L. Then we divide it by 2, and we get 250 minus pi r equals the length. We know the area of the rectangular infield, so here is going to be length times diameter. Okay. Our diameter, we can change it to be 2r instead of d. So we're going to substitute that in here. We then can multiply this to expand it, or we can leave it in this right here, because we're going to use that to get the maximum vertex. Okay, so we know maximums occur at the vertex, and they're easy to get from the zeros. Okay. This is already in the factor form, so the zeros are easy to get. So we have here area equals 250 minus pi r times 2r. Set this one equal to 0 and rearrange for it to solve for r. So r is 250 divided by pi. My second 0 is easy to note. 2r equals 0, which r then equals 0. The midpoint is just 250 over pi divided by 2, since the first root is 0. So we do that calculation here, and we get 125 over pi is the radius. The diameter is twice that, so the diameter is 250 over pi. Since we have the diameter and the radius, it's easy to get the length from the equation we arranged previously. So length is 250 minus pi r, 250 minus pi, brackets 125 over pi. Pi's cancel out, so we have 250 minus 125, so the length is 125. So to answer this question, both coaches can be satisfied with the field being 125 meters by 250 over pi meters. These measurements will create a maximum area while satisfying 2 laps around the track being 1,000 meters. For more solutions to other word problems, please subscribe to my channel, or for tips on how to use your calculator, please subscribe to my channel as well. I will leave this off here for a bit so you can see the full solution. I hope this answered your questions with regards to this problem.